Hello, I'm Dr. Ogilvy, the course director and instructor for the online histology course. And I just want to take you on a journey from early microscopy through the ages up to the present time to set a stage and perspective for the study of histology that you're about to begin. So I'm going to switch over to some slides. And the first slide brings to mind the discipline of histology. What is it, its relevance, and how is it studied? You can see me at a dual viewing microscope in my office before I retired from full-time faculty member at the Medical University of South Carolina, where for many, many years I was in charge of the medical histology course. So histology is the study of microscopic architecture and function of an organism. And in this case, the course focuses on the human body. Now, the naked eye can only resolve two particles or two structures if they're separated by 1/10 of a millimeter. And 1/10 of a millimeter is equal to 100 micrometers. So if you have two objects before you and they're separated by that much, you can distinguish them as two objects. If they're closer to that, they will appear as one object. So that's resolution. If you can separate something in reality that's really separated, then you have resolved them. The structure of an organism, as seen through the microscope, can be resolved with a better resolution or better resolving power because of the lenses used in a light microscope. And there the resolution is 2/10 of a micrometer. Now it takes 1,000 micrometers to make even 1 millimeter, so that's pretty small. The discipline is known also as microscopic anatomy or microanatomy. And any structure that we study will have a function. So structure determines function. And we're going to look in the course, and I guide your study in learning the structure-function relationships. So how is histology studied? Well, first of all, in the upper left, you have to take fresh tissue. Then you immerse it in a fixative, and that is usually commonly formaldehyde. And what happens there is the fixative kills any bacteria, prevents any growth occurring, and it cross-links the protein and makes the tissue hard. And then you go through a series of dehydration and mixing with alcohol and organic compounds that are miscible with paraffin, and you end up embedding the specimen in paraffin. And this, in the center of the image, is a paraffin block with the tissue in it. Then you mount that paraffin block on a microtome and make thin sections. And then you float those sections on a warm water bath and put a glass slide under it, and then the specimen is on a glass slide, and you dry it. And then you go through a series of dehydration again, and with alcohol, and then subject the section to some stains. And here you see in the right middle a glass slide in which the tissue has been stained, and then it's ready for microscopy. Now, in the course you're about to embark on in WebMic, there are 3 lessons that you can retrieve by clicking on histological technique. They are very well done, and they were prepared by the staff and the leadership of Dr. Peter Grosskirch, who is he's the main author. I'm the co-author of WebMic. And I spent 1 year with him at the University of Zurich, and we advanced WebMic from where it was before I began to where it is now. So if we go here, I want to give you a little historical perspective. First, we start with microscopes. Now, this is not a detailed history lesson in microscopy. Just some highlights. Johannes Lieberken, who lived from 1711 to 1756, he was one of the first to use a solar microscope, and also was used by Thomas Jefferson, where you could project the image upon a outside of the microscope so people could gather around and look at it. Photographs through the microscope began probably, say, in 1830, was probably the first photograph taken through a microscope, and those would be named photomicrographs. Now, Richard Kerr is seen here in 1904 with a huge bellows. At the end where he's looking would be a glass plate, and he has a microscope, and he had a light source over here on the right illuminating through here, and he would have a plate that was photographically sensitive, photosensitive chemicals on it, and made a photograph. The very first photomicrograph was published in 1853, and by 1880, the routine use of lantern slides. Now, these are fairly large slides that these photographs were embedded between glass, and they were put in a projector, and then you could project them on a screen or a wall. But by the middle of the 20th century, photomicrographs became routine in medical textbooks. And this is kind of interesting, I think. If you consider data storage, photomicroscopy, and virtual microscopy, look at the black line beginning here in the graph, and then documents here on the left going up to 250 per year. And if you start with 1958 and you progress, you see that publications of virtual microscopy. Now that's a more advanced microscopy where you now are taking pictures through the microscope with a digital camera and even scanning whole specimens and making them zoomable. And so virtual microscopy really took off after Silage and Gill in 1985 developed the first apparatus in order to not just take a still shot through the microscope, but actually scan the whole specimen and then put all the little tiles together and make a huge image that you could zoom in and pan around. And then Dr. Fred D., one of my colleagues, a pathologist in Iowa, he put up the first collection of histology and pathology slides on the internet. And that collection you have actually access to. So you can see how the publications grew. But in the meantime, if you back up to 1951, the first video tape recorder. But the most significant thing in 1975 was the first digital camera. Before that, between 1959 and 1975, you had an analog camera that you could take photomicrographs and make them through the microscope, and it was on film. But now in 1975, you could put it on a computer. You could save it to a hard drive. And then by 1985, you begin to have virtual microscopy. And look down here, in the age between 1950 and 1980 is the era of analog photomicrography, and then the era from early 1980s through today, digital micrography. So down below, though, you can see that on computer in 1951, it was punch cards and then magnetic tape. And then in June of 1983, the first hard disk drive, you could save something to your computer, and then a CD-ROM. And then by 2000, you had the USBs that you could put in and save on a flash drive. And then the DVDs by 2006, and Blu-ray discs, et cetera, and now almost everything is shared over the internet. So if we go back to 1898, this is what the histology lab looked like at the University of Buffalo. And here you have the medical educator was very important because the teacher had to go from student to student and peer through the microscope to see what they were seeing in order to help them understand whether they were identifying the structure they were looking at correctly. And then this is the Medical University of South Carolina lab in 1963. And there you can see students peering through a single eyepiece and also two eyepieces. In other words, a monocular right beside a binocular. Now, this monocular microscope would be cheaper than this binocular. When I started, and I'm going to shift over to me, when I started in my career as a student, I was using a microscope like this. And I had to shine a light here or go to a window and get light to shine through so I could see the specimens. And as I then became a faculty member and researcher, and I was able to purchase a much better microscope. This is far more expensive. It has a built-in light source and very fine objectives with good resolution and eyepiece and a stage that I could move around easily with controls. So I'm back to and progressing through here. In those years, and up until, say, well, even recently in some medical schools, but not many, or in undergraduate histology courses, but I think that many now are digital and virtual. But these are the glass slides that you saw earlier in this talk, and how they were prepared. And this is the slide collection that was shared and loaned to one of two students. Used to be that every student got their own slide box, and in the distant past, they had 3 boxes of slides to look at and study and learn and be tested on. So this is a box of not quite 100 slides. And if we look over here on the right, you can see the groupings of cardiovascular organs, lymphoid organs, GI tract organs, endocrine, female, male, and integument, or the skin. So this was the resource to study, and the slide had to be put on a microscope, and the student peered through it. And again, the professors had to go from student to student, peer through the microscope. There was a pointer there, and the professor had to determine what the student was looking at and then try to help the student understand what they were looking at. So this is an example of a human aorta stained with a very routine hematoxin eosin stain. And here is a human aorta underneath stained with elastic stain. Now you see the elastic stain is very dark because the human aorta has up to 70 elastic membranes. And they are stacked together, and there's tissue and cells in between that holds them together. And so the aorta is very elastic, and when the heart ventricle contracts and sends blood into the aorta, it expands. And then when the heart is relaxing, the ventricle is relaxing to get ready to fill with the next amount of blood, the aorta snaps back, and there are valves in back, and that keeps the blood flowing well, and you usually get a normal pressure somewhere between 120 millimeters for systolic contraction and 80 millimeters for diastolic relaxation. Now, this is a human liver, and you can see that there are different stains, hematoxin eosin, and then a trichrome stain we use to emphasize collagen to see the framework of the organ. That is the stroma that holds the functional part of the organ, the cells, the parenchyma. And then at the bottom is a very dark stain of the liver, and that's stained with silver. And the silver stain is used to stain very tiny reticular fibers that form a network that holds all of these delicate liver cells so that they're held in place and the liver can function. So you will learn in the course different stains and what their purpose is. So photomicroscopy. On the left is an analog camera. On the right is a digital camera. Now, these photographs that are taken either with the analog camera and put on film, or the digital camera and digitized and put in stored on a computer, they're static. You can't zoom in and pan around on these specimens. They're very good and been very, very useful. But the advancement has been in being able to actually not take a snapshot, but put a specimen on. And you see on this top image here, this microscope has a motorized stage. And when it's all set to go, and with the computer software, you start at a certain place, and then that motorized stage will advance frame by frame or tile by tile with the computer operating it and taking a photograph at each point. And then when it's all done, the computer software fuses all those images into a large specimen that could be up to 1,000 megabytes or 1 gigabyte. Now, if you take a picture with your mobile phone, it's probably not going to be much larger than 3 megabytes. So there's a perspective for you. And actually, a digital scan of a glass slide that has 15 millimeter by 15 millimeter specimen on it, using a reasonably high magnification objective, can produce an image that's about 2,500 square feet. And then now, how do you look at that over the internet? Well, the software on the server and the client viewer, when the client requests a certain magnification, a certain region, then the server only sends that information. So therefore, it's possible to view and pan around and at different magnifications in different areas in this large specimen without downloading the entire 1,000 megabytes. Now down below you can see that a very modern scanner, the microscope is enclosed. So that's a whole slide reproduction compared to a digital or analog snapshot, a photomicrograph. Now, in the course, you're going to be looking at specimens in WebMic, and these I just put a couple examples. On the left is a skin, and that is actually left and right is skin. And on the left, you can see on the tab above, you have 5x, 20x, 20x, 40x, and 40x of tabs. You'll be able to click through those tabs and see increased magnification. For right now, it's clicked on 5x, and so in the WebMic, it multiplies that 4 times when you view it, so that's 20x. But in the right one, the tab is on 40x, and WebMic magnifies that in the viewing area to 160. But these are snapshots. You cannot zoom in on these. When you pick an image, you can move around on it, but you cannot zoom in on it. But you also have the opportunity to view and study whole slides, which gives you a feeling that's very much like you're looking in a microscope. Now, I couldn't reproduce that here, but you'll soon be able to see that when you are looking at the specimens using your client BioLucidity viewer, and you're retrieving the specimens we've set up for each of the modules, and you'll be able to go from low power, medium, and high power, and not snapshots, but you can actually zoom in gradually and zoom out and pan around. So the rise and evolution of digital imagery and histology has yielded now specimens and resources that are far, far beyond the early development of the solar microscope back in the 18th century. So, and we can put images in software and label things and so forth so much easier than we could in the past. Now, I just want to spend a couple moments talking about electron micrographs and electron microscopes. The electron microscope uses electrons to illuminate, not photons. And we will have a few electron micrographs in the course, but not many, because this course is all about basic histology. It's about fundamental basic histology. And if we had an electron micrograph for all of the specimens you look at, the course would be much larger. But I just wanted to let you know that the very first publication of a TEM, that's a transmission electron micrograph, was by a group of investigators, and you see Dr. Porter right there in the middle at his microtome, which cuts sections on the order of 50 nanometers, 50 to 80 nanometers, rather than 0.2 of a micron, because you have to have the section extremely thin in order for the electrons to transmit through it. And what you're looking at is really kind of a silhouette of the specimen. And that was published in 1945. And then in 1963, Dr. Porter and Dr. Bonneville published one of the first atlases of fine structure of cells and tissues. And on the right, you see white blood cells and fibrin that's in the blood when it coagulates. And that's a scanning electron microscope. Now, when you are in the lecture on microscopy in the course, you will actually be introduced to both a transmission electron microscope and its resolution and the scanning electron microscope. So the course microscopy is the primary resource is WebMic. You can see on the right, and when you get in there, you can see that the concept and design originally, back before 1999, was conceived by Dr. Hans-Peter Rohr, a medical doctor and pathologist in the Neocortex Foundation of the University of Basel. And then Dr. Peter Grosskirch, my colleague, who I still communicate with in Switzerland, who is retired but still working like I am, and myself are the source of illustration, labels, and the legends. And the initial programming was done by two programmers in Basel. And then the initial visual and text editor was done by the wife of Dr. Hans-Peter Rohr. Now you can see below that the conversion of WebMic to HTML5 was by Andrea Meyer, a senior software engineer, and that occurred in 2019, which enabled WebMic to not be blocked by the security levels that Chrome and other browsers are beginning to apply, and the discontinuing of support of Adobe Flash by December 2020. So you're going to use WebMic in combination with the laboratory exercises of histology, a guide for the study of WebMic specimens that I am the author, and that is now an electronic book with interactive questions and ability to take notes, create flashcards. And one of the most helpful additions, according to students, is that I have created 150 very short 1 to 6 minute videos that give you a tour of each of the WebMic specimens you're assigned to study. So just back up. The textbook in the course are my lectures that are in form of PDFs as well as narrated and dynamic. But, and I don't assign a textbook other than the lab manual, because the lectures and the PDF and the narration suffice as the text. But one of the earliest textbooks was by E.A. Schaefer at the University College in London. And on the right, you see drawings of the lung. On the top here is actually a lung as a section where you can see the alveolar septa and some of the cells outlined. And then down below, you can see what looks like little channels, and those are capillaries on the surface of alveoli. Well, back then, in 1885, These were being drawn. These are drawings all through this specimen. Okay, so we're getting near the end of this presentation. I want to bring to your attention an article that was published in 2015. It's entitled, Once Upon a Microscope Slide, The Story of Histology. This is a very interesting account of histology from early to more recent times. It's available on the course welcome page or the course website as a PDF, and very worth taking time to read. So, in conclusion, I'm the instructor, you are my students, and we're connected by the internet. I'm in my location, you're going to be in many locations, but we can still connect and you can still learn. So, I want to wish everybody success in the course. The course website and the resources are designed for you to be successful. All you have to do is follow the plan in the course, and we give you a plan, and former students we put on the course website so that you are provided with sufficient advice of how to be successful in the course. Just put in the time, develop a schedule that you can stick to on a regular basis, and I wish everybody total success in the course. Goodbye for now.